Just for further background, ladies and gentlemen, I've been in the industry a rather long time, and my forte is one of tackling really difficult problems. This morning, I'm going to speak a little slower than normal to give those English speakers in the language in the audience and the translators time to assimilate what I'm saying. This slide set I'm going to put up is fairly animated, and there will be time at the end for questions and answers. You immediately have access to my homepage, where there are rather a lot of slide sets on presentations on many topics. If you just go to petercochrane.com and go to presentations or movies, please download whatever you need. No copyright, it's yours to use as you see fit. So here's the title, and I want to explain to you why Industry 4.0 is absolutely key to sustainability. This is our history, starting with the Industrial Revolution in the UK in about 1760. We have progressively built better and better technologies right up until today, but unfortunately, along with all the good things, as in the living standards of people and the health and the population size, we've created a waste problem, we've wasted energy and materials, and we've created immense pollution. And this is having some interesting outcomes. It looks as though the planet is reacting in two ways. One, climate change and extreme weather conditions. We've had a lot of flooding in Europe over the last year, including the UK. And now it would seem that the biosphere is reacting and creating some rather nasty viruses. And believe me, I don't think CV19 will be the last. So the big question is, what are we going to do about it? This situation, which is generally applicable across the planet, is absolutely unacceptable and untenable. The reality is that recycling, as people are publishing and describing it, and how the politicians are celebrating it, just does not work. Landfill, the burning of precious materials, is just now on a gross level. And so we have to reduce this waste. And my view is, actually, there's no such thing as waste, only poorly exploited resources. We have to think again. This is all about a systemic failure of design and material choices and processes and use. And we have to look at the whole cycle. Now, to give a measure of our overdemand on this planet as a species, we are consuming something of the order of 1.5 times more raw materials than this planet can sustain. And so if we do not rein back under our own doing, then I'm afraid the planet will bite back, and there will be some severe consequences. So the key to always remember, and I keep reminding people, there's nowhere else to go. This is it. We live on a closed system. The resources we are using are finite. There's no more. Once we've burnt the oil, it's gone. And oil is a precious material, and we really ought not to be destroying it. We really need it for making things and creating pharmaceuticals and many other products, including clothing. This statement is absolutely true of all life forms, and we are attempting to live and prosper in our own waste materials. It isn't going to happen. Any closed system will collapse if the waste materials overpower an organism. So a further perspective here is, well, this is where we are. We have a standard of living, we have a way of life, And for those people who think we might be able to go into reverse gear to some old ideal where things were much better, that is not the case. Technology is an absolute ratchet of progress. And if we want to go back to some earlier time, then we can't support the population. So in a sentence, if we attempt to reverse gear from where we are to some past time, it will see the death of many people. A further observation on all of this is that polishing or improving all our old industries and making more and more efficient production lines only slows down the eventual decline and demise. We have to think anew. We need an absolutely new approach to industry, production, and the way we live. So what to do? Well, this is the list that the idealists come up with, and it's a really good list. Yes, we should be doing all of these things, but there is a snag. Nobody knows how to do it. And I'm going to suggest to you that Industry 4.0 happens to be the kernel or the core of the viable solution, and all the key technologies we have to hand fall under that umbrella. So this is an industry view of Industry 4.0, and it's almost complete, but not quite. There are a few aspects and things missing, and I want to fill those in for you. But you will recognize all of these technologies as existing and being viable and available and well tested. But the vital extras that we need center on nanotech, biotech, and materials, which are core, AI design and control. We've already got AI designing the chips in all our devices. The robots are actually building all our devices. And so we have to bring that under the Industry 4.0 umbrella, along with integrated cybersecurity and human-robot team working. So reuse, recycling, repurposing with all these additions is where we have to go. So I've made a graphic for you that shows the intersects here of AI and robotics, which I'm sure you'll recognize is vital to modern industry. This is what is powering production, and this is why we're getting such terrifically good quality products at such a low price. But for Industry 4.0, we need a combination of nanotech and biotech to create new materials. And this is the hotspot of all four. The coalescence of these technologies actually is going to drive the Industry 4.0 revolution. But there is a wrapper, and that wrapper is the Internet of Things. And now the story is almost complete. The Internet of Things is about orchestrating all the things we manufacture, all the materials that are in there, how we recover them, we reuse them, we recycle, repurpose them, is critically dependent on the IoT. So day one, design in. It's been my observation throughout my engineering career that all products and all production actually focuses on the core problem. And then right at the end, someone will realize that, oh, we need some security, and it is bolted on at the last minute. Or now we need to be able to find the product, have a look at how it's being used, see what materials it's made of, and how we might recover the materials, or indeed reuse the product for some other purpose. That is in the IoT. And the snag is the IoT is now an add-on at the last moment. And this is a slightly dangerous situation, and it's not going to serve us well. So here's that future I'm trying to promise you, where we've got new materials and processes, greater utility, and a massive reduction in the creation of pollution, but also in our energy demands, all with better performance. Can we do it? I think we can, and we have evidence to say that is the case. And embedded automated cybersecurity is a feature that we're now working on. Now, we only have time during this morning for me to show you one exemplar, and I've decided to pick on one that's highly complex. We use it every day, and it's due for a big change. So let's just look at one component here. Here's the internal combustion engine. It is phenomenally complex, incredibly expensive to build, very inefficient. It burns oil, and it's not eco-friendly. On the right, you'll see the assembly of an electric motor where most of the parts have been printed rather than being machined. And so the simplicity of the electric motor means we can save a vast amount of expense and materials in manufacturing the prime mover. So we have a product that's far more suited to automated design, manufacture, integration, and robotic assembly. So here's a production line, and you'll see that we're certainly using quite a few people, and these people are doing things that robots can't quite manage yet. And here goes the engine and the drive chain being put into place. That is phenomenally complex compared to what I am about to show you is being developed. Electric vehicles require far fewer components throughout, and they're so much easier for automated production lines to assemble without the interference of people. So I've picked on one other element to exemplify what I'm saying, and it is the wheel. So the pneumatic tire has served us well, but we now have the ability to get rid of the pneumatic tire, print wheels, and print the tires onto the wheel. And we're going back to solid tires. So on the top right, you can see a deformation of a wheel. This program was originally started by DARPA, and you can shoot out about 70% of the spokes and the wheel continues to function. But now the industry has had a realization that one, we could ship powder and manufacture wheels and tires at the point of need, but also there is an opportunity to add more value. And that value is to actually take the wheel from just a bolt-on item to an integrated hub where inside the wheel is the electric motor, the suspension system, the brakes. And this is revolutionary in that, one, it changes an industry that just makes pneumatic tires into one that makes active components, but fully integrated wheels makes the construction of a vehicle so much simpler. So now there is a further hidden feature. These white dots are the sensors that are embedded in the manufactured wheel. So every element has got a sensor, and it will feed back and becomes part of the control system of the vehicle. So how does the vehicle of tomorrow look? Well, it has an awful lot of sensors, in fact, well over 100. These actually connect to a central controller that adjusts everything from the performance in terms of speed, acceleration, driverless operation, suspension, road conditions. It also has forward-looking radar and rearward-looking radar with communication with 3, 4, 5G, but also Wi-Fi, Zigbee, Bluetooth, and car-to-car communication. This is transformative. But I would like you to notice something. Absolutely none of the sensors connect directly to the internet. The aggregated information from the vehicle connects to the net via whatever is available, any one of these wireless interfaces, including car-to-car. The IoT nightmare, it opens us up to cyber attack. This gentleman is parking his car, but just look what happens when a couple of hackers have got into his car and taken over.
It's not fun to have your 2-ton SUV's brakes hacked just as you're parking in front of a ditch. Okay, hold on tight. Hold on. Oh. That's what I've learned from Charlie Miller and Chris Balasek, a pair of hackers who have spent the last year developing a piece of software that can wirelessly sabotage this 2014 Jeep Cherokee. It hasn't been altered in any way. There are no devices attached to it. But like many thousands of Jeeps around the world, it can be remotely hacked over the internet through a cellular connection to its entertainment system that would allow someone to take over its steering, its transmission, and even its brakes. To demonstrate that, I'm going to act as today's crash test dummy and drive it on the highway here in St. Louis.
So what happens is they actually take over and steer him into the side. Another revolution you should be aware of is coatings. This is exemplified here, I think, where the clothing has been coated and it's hydrophobic. It will not allow any moisture or any fluid to stick to the clothing. That can be applied now to the hulls of ships and the bodywork of vehicles. And so here's my car of the future. This is what I expect to happen. I think, first of all, the panels will be multifunctional and they will be plastic. You've just seen the hydrophobic coating. I don't expect to ever clean a car again when I get one of these, but there are other added features that I think we will ultimately be able to engineer. Each one of these features we can do one at a time, but we can't do them all at the same time at the moment. So this is not a science project, this is an engineering problem. We can get plastic to store energy, and thereby we can get rid of the battery. Effectively, the car body becomes the battery, and it delivers energy to where it's required. The second feature is the car can be color programmable. So in the morning, my wife can have a red car. In the evening, I can have a blue car, but tomorrow I could have a green car. That saves an awful lot of spray shop time. To a degree, we can also make the plastics self-repairing for small scratches and cuts and dents. That is already in existence. But from an ecological point of view, the really good news is fewer components, reduced mechanical complexity, 95% material recovery, and a 90% improvement on energy use. Now that exemplar applies to all the home appliances and office appliances. And the big worry here with IoT as an afterthought is that if manufacturers do not put on sufficient security on day one, then these devices are a gateway into your office and into your home because they will all connect to the Wi-Fi. And what we actually need is an auto-immunity security system for these devices to protect themselves and to adapt to a changing attack environment. This is what we get. A very interesting new form of network. Things talk to each other. And we've never had a network of this kind. We do not know actually how to design and build them. It is very biological in nature, and we are going to get some very emergent properties as things start to talk to each other and share information. So I'm going to give you a strap line here that's slightly provocative, but things that think want to link, and things that link want to think. So what I'm actually postulating here is the likelihood of the emergence of a new machine intelligence based on the clustering and the communication. the biggest message I have for you here is that the vast majority of things on the IoT will never connect to the IoT, and those that do connect to the IoT or the internet will do it via some aggregating terminal. You're not going to put 5G on your toaster or your washing machine or your refrigerator. You're really not. But you will put Zigbee or Bluetooth or Wi-Fi. The other breakthrough here is the realization that we actually need new forms of very short range, very low energy and very low cost wireless systems, and that's going to see a revolution in digital wireless. One further important point is the collaboration of people with machines is growing. It's happening on production lines where the robot provides an extra couple of hands to help a human, or in the case of a surgeon. The difference here is when a mistake is made that turns out to be a positive mistake, or there's been a learning experience, then 160,000 machines on a network instantly understand that change and they all reprogram. This is hyper education or knowledge, if you like, between human and machine, and is entirely new. Now, I know that there is a political move across the world for nationalization, for the destruction of globalization, and there is change afoot. And I have to tell you that there is no country, not the United States, not China, not Europe, that has all the people, all the technologies, and all the facilities to go alone in this new direction. We are going to need the human race to band together to create a future that reduces this amount of traffic. And this is just the shipping traffic across the planet every day, moving goods around. And to me, that is probably going to be the single biggest saving. Ladies and gentlemen, I hope you found that useful, and I'm very happy to take questions. As soon as I leave you this afternoon, I will be posting this slide set and you'll be able to access it, and I will email the link directly to the organizers so that you can download. But let me say again, you also have access to all my other slide sets on things like cybersecurity, autoimmunity, and voice over IP. There are many, many topics, robotics in industry, and they're all available on petercochrane.com and yours to download. Thank you very much indeed.